Hello, this is Smokey, and today I'm going to show you a 1 million items per hour Endstone farm that I built together with Little Mouse. Now, Little Mouse isn't actually here today, but he is going to make a separate video covering the blast chamber and the tools we use to come up with the final design. And I'll link that down in the description. But the whole farm itself is based off of the first Endstone farm that REUPLOAD and I built, which I will link down in the description as well. So I completely rebuilt the gateway cycling system, and the differences from the first farm are that we're using less ender crystals here, and the ender crystals are no longer directional, so you can build this in any valid location. You only need to push in 1 cobblestone now instead of 2, which speeds things up a bit. We're using a better island, which I'll talk about later. And I cleaned up some of the redstone. Now the biggest difference is the speed. So this gateway cycling setup can run on a max speed of 19 game ticks per gateway, or 19 game ticks per island, and then 38 game ticks for a full cycle, up and then back down again. So as you can see, it's quite fast, and the bottleneck now is the hopper minecart. So if this was any faster, the hopper minecart would not get bounced back up again because the slime would be too fast. So over here is the island, and if I throw this egg, it removes the island, and then the game will generate another island. So you can kind of gauge the speed by this. It's quite fast, but the actual farm itself is not running on a 19 game tick clock. Otherwise, the TNT would just blow up the items as they're falling down. The farm itself is running on a 29 game tick clock. During the designing process of this farm, our 2 main goals were reliability and the most endstone per hour. Now, reliability is an extremely important thing when it comes to a farm like this, because if there's one problem or one random factor that you don't take into account, basically the whole farm explodes. And obviously that's not a very good thing, so we did a ton of testing and it should be reliable. Now down here, there is a theoretical chance for an endstone column to form, but one never formed during our testing of the final layout. And even if your luck is extremely bad, the worst case scenario is that you'll have to come in manually and remove some endstone. But that should be the extent of your problems as long as everything is built correctly and in the exact same positions. Now let's talk about the rates. So we did a 53-hour test with no endstone columns forming, and we got approximately 1,078,000 endstone per hour, or approximately 299.5 endstone per second. Now the farm is running on a 29 game tick clock, so 29 game ticks per island. And if you do the math there, we're getting approximately 434 endstone per island. And since we're using 3 TNT, we're getting approximately 144.78 endstone per TNT. So we weren't going for TNT efficiency. If we were, that would be pretty bad. Okay, so now let's talk about endstone islands. And endstone islands are very important because there are many different sizes and positions they can be in, and luckily they are not seed specific, so as long as you do things in the same place, you will get the same island on different seeds. So there are 4,800 endstone islands on radius 768 around 00, and I explain why we are using radius 768 in the gateway shifting portion of the video. But basically we needed to find the best island out of the 4,800. So Earth Computer found the max island on radius 768, which I can show you. And we were initially going to use this island, but we later ditched it. And our problem was valid endstone locations. So a valid endstone location is basically an endstone block with a too high air gap above it. Now the game is going to be constantly checking for those valid endstone locations in a specific chunk, so in this case this chunk. And if the game finds a valid endstone location here, then the gateway will find it and basically the whole farm will blow up. So since we are harvesting the island with TNT, you know that TNT has a random range where it blows up blocks, and the difference from the theoretical minimum and the theoretical maximum TNT range is so large that it's extremely difficult to harvest a significant amount of Endstone from the bad chunk here with TNT and be safe. So right now, this variation of the Endstone farm runs at about 1.2 million Endstone per hour, but it blows up after around 2,000 iterations due to TNT random range. So right here, if this particular formation formed with this Endstone here, and this too high air gap above it, then the whole farm would blow up. Now Mouse will probably go into the TNT range stuff, but if you wanted to make this farm right here reliable, you'd basically have to cut off half the farm and avoid harvesting from the bad chunk, effectively reducing the rates by half. So that wasn't good enough for us, and Earth Computer wrote a program to find the ideal Endstone islands on radius 768. So let me just teleport back here. So what I mean by an ideal Endstone island is that the most amount of Endstone is in chunks other than the chunk the game is searching for Endstone in. So here in the final design, less than a fourth of the island is in the bad chunk. And if you want to know why this is, I will explain it in the gateway shifting portion of the video. But if you saw in the cinematic, we're not even using the bad portion of the island. And that's where I'm going to stop talking about Endstone islands. So a huge thanks to Earth Computer, who wrote the program to find the max and ideal Endstone island locations, and I will link those down in the description. Talking about Earth Computer, he also made some carpet mod log commands to help debug the gateway cycling, and I'm not sure if those commands will be added to the official carpet mod, but they were extremely helpful. So again, a huge thanks to Earth Computer. But anyways, that was the end of the general information part of the video, and the rest of the video will be more in depth. So first I'm going to go over the terminology I'm going to be using in this video. So of course you have your main end island, your outer end islands, then you have your entrance gateways, and these are the gateways naturally spawned by the dragon at the main end island, and you're limited to 20 of them normally. Entrance gateways are the default state for gateways, so if you set block to gateway in with commands, it would default to an unopened entrance gateway. And once an entity or a player goes through an entrance gateway for the first time, it is permanently linked with its exit gateway location, and then you can never use that entrance gateway to generate another Endstone island or another exit gateway again. And of course you have your exit gateway, and these are the gateways generated at or near the outer end islands from going through an entrance gateway, and then they are permanently linked to their entrance gateway location. You also have your random gateways, and these gateways spawn randomly throughout the outer end islands, but it's predictable, and going through them takes you back to the world spawn point, which is the obsidian platform. If you push one of these while it generates, which is similar to generating a pig spawner, it will become an unopened entrance gateway, but not tile entity-less. ZeroX made a video about this, and I'll link that down in the description, but this information will be useful to know later on in the video. Now you also have your tile entity-less gateways, also known as dataless gateways. Dataless is just a short way of saying tile entity-less. So dataless gateways are created when you perform TED, which is tile entity data deletion, or just tile entity deletion, however you want to call it. And you perform that bug on an exit gateway while it spawns. And in a nutshell, TED is just removing the tile entity portion from a tile entity block. And dataless gateways do not teleport you when you stand inside them, and they look invisible after you relog. However, sometimes they can just randomly reappear, but they're still dataless. And they are safe from server restarts and chunk unloading/reloading, but they do not get saved properly in structure blocks, which is a whole nother topic I'm not going to cover in this video, but it's interesting. And you can also get the remote getaway advancement by walking into a dataless gateway. Next is updating tile entity list/dataless blocks, and what I mean by that is when the game checks for a tile entity at a dataless block's position, the dataless block will regain its tile entity, which sets it to its default state. So for us, as I said before, the default state for a gateway is an unopened entrance gateway. So you can trigger this event with hoppers, minecart hoppers, ender pearls, and control plus middle click in creative mode if the block is middle clickable. So that wouldn't work on gateways because they aren't middle clickable, and you need to be in creative mode, so obviously it's not survival friendly. Let me show you what I mean by the updating dataless blocks thing. So right here is a simple setup that Myron showed to create dataless skulls. He actually showed it to delete the contents of a shulker box, but you can apply the same setup to skulls and all other tile entities pretty much. But yeah, so we're using ender crystals to perform the TED bug. In the actual Endstone farm, we're not using ender crystals to perform the bug. We're doing something different. I'll talk about that later. But yeah, if I just flick this lever, this right here is actually a dataless skull. If you relogged, it will turn invisible, but you don't need to. Well, that's locked. Okay. So I put an item in this hopper. The skull turned into a default skull. And so that's basically what we're doing here is we're turning the tile entity list block into its default state. So for gateways, it would turn the tile entity list one into a default unopened one. So like I said, here's another one. You can see I throw an ender pearl at it. Let's try again. Oh, yep, okay. Third time. Turned into a skeleton skull. And the same thing with control middle click if you're in creative mode. So if the block is middle clickable, so skulls are middle clickable. So if I just do that, yeah, as you can see, it turned into a skeleton skull. And yeah. Oh, and one more thing I should have mentioned is that hopper minecarts work the same way as hoppers pretty much. So we have a dataless skull here, and then with minecart hoppers, it doesn't actually visually change until you relog, but server side, it did turn into a normal default one earlier. It just doesn't update for the client, unlike hoppers themselves. Alright, so there's one more thing I need to mention, and that is block normal cube. So there are a couple different normal cube definitions in the code, and gateways use is block normal cube for the normal cube checks they do. And this is different than is normal cube, which is the definition the gray carpet checks for in carpet mod. So here are a few examples of is block normal cubes right here, and here are some examples of non-is block normal cubes. And this is extremely important to know because you need to know what blocks you can and cannot have in certain areas around the farm. So yeah. Let's jump into gateway shifting. So a lot of the stuff I'm going to be talking about here has been explained before in videos by people like Nembon and Ray's Works and research by Narcoleptic Frog. Now all of this is about exit gateways and manipulating where they will spawn and occupying chunks and stuff like that. But all of the information there is relevant to this, so I'm going to be building on top of that knowledge and also explaining it as well. So the first thing you need to know is that everything depends on the vector from 0, 0 and the specific entrance gateway you're working with. It doesn't matter where in the end the entrance gateway is. All that matters is its vector coming off from 0, 0. So this diamond line down here is representing 0, 0 and the vector created by this entrance gateway. So when you go through that entrance gateway for the first time, what it's going to check is where that vector hits radius 1024, and this is where it hits radius 1024. At radius 1024, it is going to search an additional 256 blocks on the vector to see if those chunks are occupied or not, and it's going to check minus 256 blocks on the vector from radius 1024 to see if those are occupied. If the chunk at radius 1024 is occupied, it does not care about the further chunks So basically what we're dealing with here is the chunks the vectors on from radius 1024 to radius 768 right here. So what do I mean by occupying a chunk? So occupying a chunk is if there is a block above the first subchunk. So currently the game would not consider this chunk occupied. However, if there was a block or a flying machine run through these chunks at y16 or higher, then it would consider these chunks occupied forever. For some reason, when you MC edit a floor at y0, it occupies the second subchunk and maybe the subchunks above it too. So that's something to look into, but normally you would have to run a flying machine or place blocks in these chunks at or above y16. So why occupy the chunks between radius 1024 and 768 in the first place? Well, there are two reasons for that. The first reason is that if you have already occupied these chunks and you wanted to gateway shift further out, there is absolutely no way you could do that. So if someone bridged and occupied the chunks, you wouldn't be able to do it. So the safest option is just to do everything at radius 768 and occupy the chunks, because you'll know that they've been occupied and nothing can change that. Now the second reason is because it's actually simpler to gateway shift at radius 768, because there's more area to cover if you're gateway shifting on radius 1024 compared to radius 768. But of course you could gateway shift a little bit closer in or at radius 1024. That's just a slippery slope because you don't know if the chunks have been occupied or not. Once the entrance gateway checks to see if all the chunks on the vector are occupied between radius 1024 and radius 768. If they're all occupied, then wherever the vector intersects radius 768, this will be the chunk where the game is going to be searching for Endstone. And it's going to be searching for valid Endstone locations. Any Endstone block at or above y30, so if there's an Endstone at y29, this would not be a valid Endstone location. And there also has to be two non-isblock normal cubes above the Endstone. So this right here would not be valid. This would also not be valid. But this right here would be valid. This would also be valid right here. But something like this would not be valid because there's an isblock normal cube above this Endstone, 2 blocks above it. And then there's an isblock normal cube above this Endstone as well. Once the game finds a valid Endstone location, that is where it's going to start the search to place the exit gateway. Now it's going to search 16 blocks in each direction from this Endstone, and it's going to be searching all the way up to the world height limit for the highest isblock normal cube. So in this case, the highest isblock normal cube is this gold block, and it's in the far corner of the 33 by 33 box around this Endstone. So if I were to place a gold block here, it would not find this. And so right now, the exit gateway would spawn above this gold block, 10 blocks above it. Now if there's 2 blocks on the same Y level, it prefers the most northwestern block. Alright, so now that we know that, basically what we're trying to do here is to generate the exit gateway where this brewing stand is and perform the TED bug on it while it generates. And when you perform the TED bug on the exit gateway, it will turn into a tile entity-less or data-less gateway. However, instead of using ender crystals to perform the TED bug by blowing up the ticking tile entity, we're actually using the exit gateway's generation itself to delete the ticking tile entity. And that ticking tile entity cannot be an isblock normal cube, otherwise the gateway would just find it and spawn on top of it. So for example, a furnace is a ticking tile entity, but the gateway would find it and then spawn on top of it. So we need a ticking tile entity here that's not an isblock normal cube. The cheapest option would be a chest. However, I like brewing stands because you can see them from a lot further away. So I'm going to give a brief rundown real fast of the TED bug. Now, first of all, this brewing stand is going to tick, and then in the same tick, the exit gateway is going to spawn here, but after the brewing stand is ticked. Now, the brewing stand tile entity cannot remove itself until the next tick because it has already been ticked. So when the next tick rolls around, the brewing stand tile entity will get ticked again, but it realizes that it's been removed, so it deletes the tile entity at its position, which happens to be the new exit gateway. So basically it's removing the tile entity from both the brewing stand and the exit gateway. If you want to learn more about the bug, I'll link down to Earth Computer's code analysis and explanation of the bug, which is probably a little bit better than my explanation right here. Alright, so there's one more thing that you need to do before you perform the TED bug and start gateway shifting. So you need to get the tile entities in a specific tile entity order. More specifically, this brewing stand and the unopened entrance gateway at the main end island. So this brewing stand has to be loaded in the world before the entrance gateway, and the easiest way to do this is to have one player stand here and load the brewing stand, and then make sure that the entrance gateway is unloaded, and have another player go and load the entrance gateway. And now you're ready to begin gateway shifting. Now all you have to do is throw an item through the entrance gateway, and this will generate the exit gateway where we're gateway shifting and turn it into a dataless gateway. Now you can throw an ender pearl through it to teleport there. Now what you don't want to do is throw an ender pearl through it first. You have to throw an item through it first, otherwise it will not work. So here we are. Now as you can see, we have a dataless gateway here. Now sometimes it may still look visible. What you can do to check is relog or throw an item into it. If the item gets teleported or the gateway is still visible when you relog, that means that you did something wrong. But if you have a dataless gateway here, then you're good. So now when I update this dataless gateway with the hopper, it will turn into an entrance gateway, and then the whole cycle basically continues. So now there's a new vector from here and 0, 0. So you can kind of imagine a vector right here. And now, wherever that vector intersects with radius 768, that is the chunk where it's going to be searching for Endstone. So in this example, it's going to find the Endstone here. 16 blocks this way, another 16 blocks this way. It will spawn the next dataless gateway here. Now you can probably see where we're going with this. Now there will be an entrance gateway here, and now there's a new vector, and it intersects radius 768 right here in this chunk, finds its endstone, and continues. So I can demonstrate this. You place a hopper here, and then you put one item in the hopper, and you can see that it updated. So if I throw an item through this, it generates the next dataless gateway. And this one is dataless, so if I throw glass into it, I pick it back up. And if you relogged, this would turn invisible. So I can just continue doing this. Like this, and then you just continue all the way to the farm. Now there's also another thing you need to look out for when you're building a setup like this. You need to make sure when the next exit gateway finds the endstone that the previous gateway is out of range. So if I bridge 16 blocks this way, you do not want it to find the previous gateway. Otherwise the gateway would just spawn on top of the previous one. So that's why we're kind of alternating where we, what side of the radius we're putting the gateway. And yeah, if you ever want to stop gateway shifting for some reason while you're doing this, make sure to leave it in its dial-less form. So when you start gateway shifting again, the brewing stand will be loaded first, and then when you update this, then this will be added to the tile entity list after that. So keep that in mind as well. So if you wanted to, you could gateway shift all the way around the main end island and have a bunch of gateways everywhere. But you could also create a program to help you do this. With this visualization here, it's quite simple because you can see pretty much eyeball it and see exactly where it's going to hit radius 768. But you could also do some simple math to figure that out as well. Big thanks to everyone involved in the new gateway shifting research, namely Command Block Guy, Ray, and Earth Computer. But now let's shift on over into gateway cycling. Now let's talk about a different scenario. And this scenario is where the entrance gateway does not find any valid Endstone locations in the chunk where the vector intersects radius 768. So we're going to have the entrance gateway be cycled on this exact block, but at different y levels. And different y levels don't matter, just the x and z. So the point on the vector where this entrance gateway is going to intersect radius 768 is this exact point right here. So x399 and z655. And you also have to pay attention to the decimals. So that point is approximately right here on this orange glass. So this is going to be the chunk where it searches for valid Endstone locations. But because it doesn't find any, it's going to spawn a new Endstone island. So it's going to take the point where the vector intersects radius 768 and add 0.5 in the positive x and z directions. So the middle of the island is going to be right here where this yellow glass is in this chunk. What this means is that the game is going to be searching for Endstone in this chunk, but because the middle of the island is in this chunk over here, that means over 3/4 of the island can be in chunks where the game is not actively searching for Endstone. And wherever the middle of the island is, that is where it's going to start its search to generate the exit gateway. So 16 blocks in each direction from the middle of the island in a square like this, just like we were doing with the gateway shifting over there. So we want the exit gateway's position to end up exactly where the entrance gateway started, because as we know, we're turning the exit gateway into a dial-less gateway and then into a new entrance gateway. So basically we're just having a bunch of entrance gateways on this point. Now we want the exit gateway to generate on the border of where it checks to give us as much freedom as possible when it comes to is-block normal cubes. So right now we could have an is-block normal cube right next to where the exit gateway generates. But if we cycled the gateways on this point, for example, which may or may not work with the current vector, you would have to move the is-block normal cubes back one. And that also means more bedrock removal. So for example, right now, we don't have to remove any bedrock on this side of the gateway,